This is a fun geometry problem from the 1990 Mu Alpha Theta competition. We are asked to find this shaded area, given that triangle ABC is isosceles right, the midpoint of AB is the center of semicircle AB, and point C is the center of the quarter circle AB. We're also told that the hypotenuse AB of the isosceles right triangle has a length of 2 root 2. Using all this information, we need to find the shaded area. The way we're going to do this is by taking the area of the isosceles right triangle, adding the area of the semicircle, and then subtracting the area of the quarter circle, which is going to leave us with, it's going to take me a while because this eraser is so small, it's going to leave us with that, the desired shaded area. So let's start calculating some areas to solve this problem, beginning with the area of semicircle AB. The area of a semicircle is, of course, 1/2 pi r squared. So what is the radius of this semicircle? Well, we are told that the midpoint of AB is the center of the semicircle, which means AB is a diameter of the semicircle, and so half of AB, this segment here, is actually a radius. Now we know the length of AB. It was given to us as 2 root 2. Thus, half of AB, hence the radius of the semicircle, is half of 2 root 2, which is just root 2. So the area we're looking for is 1/2 pi r squared, but where r is root 2, so root 2 squared. Root 2 squared is 2 times 1/2 cancels out, and so the area is just pi. Now, in order to calculate the area of this quarter circle, or the area of the isosceles right triangle, we will first need to know the length of the legs of the isosceles right triangle. If we say call this side length opposite angle B, if we call that little b, then because this is an isosceles right triangle, this leg also has a length of little b. Thus, applying the Pythagorean theorem, we have that b squared plus b squared equals the hypotenuse squared. But of course, the hypotenuse is AB, which we already know has length 2 root 2. So that's 2 root 2 squared. 2 root 2 squared is 4 times 2, which is 8. So we have that 2b squared equals 8. Dividing both sides by 2 then gives us b squared equals 4, hence b equals 2. So the congruent leg lengths of this isosceles right triangle are 2 and 2. So then what is the area of the quarter circle AB? Well, that would just be 1/4 of the area of the whole circle. So 1/4 pi r squared. R, as we just figured out, is 2, because a leg of this isosceles right triangle is a radius of the quarter circle, since C is the center. So it's 1/4 pi r squared, where r is 2. The 1/4 and the 2 squared cancel out. The area of the quarter circle is also just pi. All that remains now is to calculate the area of the isosceles right triangle. That's just 1/2 base times height. The base is 2, the height is 2, so the area of the isosceles right triangle is 1/2 times 2 times 2, so 1/2 times 4, which is just 2. Finally, let's bring it all together. Like I said, what we're going to do is take the area of the semicircle, add the area of the triangle, and then subtract the area of the quarter circle. If we subtract that, that's just going to leave us with the area we desire. So the area of the shaded region is going to be the area of the semicircle plus the area of the triangle minus the area of the quarter circle. Now we know what all those numbers are. It's pi plus 2 minus pi, which is just 2. That is the area of the shaded region. Let me know in the comments if you have any questions, and if you want to see some more interesting math problems, check out my playlist in the description. Thanks a lot for watching. I'm the mathematical menace, the machinations of mankind. Two calculators at the same time, hand signs and abacus, finger count and calculus. I'm a V to the T, my parameter the rapidest. Happens like this, my lecture's the most prominent, dominant. Call me De Morgan, I get the compliments. The union in together like any time that we intersect, cause my opponents know they need